All right. Well, first of all, I want to say thank you so much for being here, and I want to thank Matthias, Jan, for making all this work and all the volunteers. So it's great to be here, and I want to talk about something that we do every day, but I want to talk about non-programming parts first of all, and then we'll transition into software development right after that. But I want to talk about decisions. Who here had to make at least one decision today so far? Yeah, that's pretty much everybody, right? At least one. And I think the most difficult one was getting out of the bed, wasn't it? That always seems to take a lot of effort. Well, in my case, I start my day pretty early, usually about 3:30 in the morning. And it so happened that I had to go to bed late last night. And of course, my wife, who is with me, I'm very happy for that, was concerned, and she asked me, but in a hurry, she said, "Do you have to wake up tomorrow morning?" Missed the word early. And my response was, "I don't have to, but I certainly hope so." So I'm definitely happy to be awake and here. And that's one thing we always have to do is the decisions that we have to constantly make in our lives. But sometimes we get carried away, and we, in our mind, deep down, think that decisions are a switch we flip. Yes or no, true or false, like it or don't, I want it or I don't want it. And what do you want to do, Angular or React? Or do we want to use Spring or something else? So we tend to really make these decisions, and we tend to get stuck deeply on it. I was recently talking to somebody, and for some reason, the word performance got stuck in their head. And it doesn't matter what we talk about, it'll go back to performance. So sometimes we have these decisions in our mind, and we feel like they are switches. But over the years, I've been thinking about it more and more about how we think as humans and how we work towards things. And decisions can be really hard. It's not easy to make a lot of decisions. It takes effort. One of the problems with making decisions partly is, however we may believe it to be the case, at the end of the day, there is emotions involved in it as well. And we are attached to certain things. And whether we know it or not, whether we like it or not, that seems to influence what we think and how we react to it. And that really makes it harder as well in the long run. But having said that, the environments can make things really hard to make decisions. Where we are, where do we work, what kind of meeting are we in, what did we come in with, all the baggage we carry with us can make things really hard as well. But having said that, I would say that we need to have a will to change our decisions. And that's one of the things I always look for in people is it doesn't matter what you decided, but are you willing to rethink about it? Are you willing to reconsider? But I will share with you one story that absolutely blew my mind because this is what I look for in people, and when you see that kind of behavior, it just absolutely enlightens your life. And for me, that experience was about a year and a half ago, a little bit earlier than that. And I really we wanted to build a house. And as you know, building a house is an enormously expensive operation. It takes a lot of effort. It takes everything you have in it. And anytime I go tell somebody I'm building a house, in all seriousness, they would immediately tell me, "I'm really sorry to hear that." And I'm like, "Oh my gosh, why?" And they would say, "Oh, we had a terrible set of builders. Knock on wood, I had the builder from the heaven," I would say. And the reason I say this is, we worked with an architect to design the house that we wanted to build. And the architect is an amazing person. He took a lot of time, spent time with us, understood what my expectations were, and I would look at him and say, "How did you read my mind?" And that's how capable this architect is. And then I tweeted this about a year or so ago, and that is those who compare building construction to software development understand neither one of them. And it turned out that we have a misconception of the industry, the building industry. Well, when the architect decided to show us the design, among other things, the front of the house, as you can see in here, has 3 steps to go in. And similarly, the garage had 3 steps to go in. And I went to the architect and I said, hey, this is amazing. I love everything you have designed in this house. I like it. But one thing, you have steps to walk in, just like you see the steps over here, and you got to climb 3 steps and go in. Well, my parents live with me. And they are, at the age where it's hard for mom and dad to go around. And I'm not going to be young all the time. I'm getting there as well. So what if I have to walk, go into the house? I would really like to just walk in. And the architect said, no, we can't do it based on where you want the house, the slope that you have on the property. And I spent a lot of time with the architect. Now, I'm sure everybody in this room will clearly understand when you look at it from the programming point of view as well. And so then I said to the architect, all right, in the garage, can you give me a ramp so I can push a wheelchair into it? So if I have to push a wheelchair for my parents, or maybe it's one day for myself. He said, no, you can't put a ramp. There's city code. There's a slope you have to build. There's not enough space here. It's going to be expensive. And finally, I'm like, okay, fine. We'll have the steps to walk into the house. And at 6:30 a.m. on one fine day, literally 6:30 in the morning, my wife gets a call from this amazing person. His name is Dave Hammer. He's the builder. And he calls my wife and says, hey, we are here to dig the hole to lay the foundation. And she said, oh, thanks, Dave, for calling me and letting me know. Venkat and I are busy today, so we won't be able to make it, but we trust you. Keep going. Thanks for letting us know. He said, no, that's not the reason I'm calling you. I'm just wondering, would you like a 0 entry into the house? And she's like, what does that mean? Well, it means you can just walk into the house with no steps at all. And she's like, well, thanks for asking. But we talked to the architect, and he says, yeah, I understand. But I got the guys who are digging the hole today, and they are thinking otherwise. How many times the programmers tell you? But guess what we can do? And this absolutely blew our mind. And we're like, well, are you serious you can do this? And within a day, they completely reworked the architecture, the details, and find a way to design in a way we can just walk in with absolutely no steps into the house. And of course, you have to reapply to the county, get the permission. And I went back to him and I said, but why are you doing this? And his response was, but why? I'm going to build it once, but I'm going to live there for a long time. I wish my programmers thought that way when they wrote the code. But I wrote the code already, like so. So the point is, build it for the users. And this is a lesson I learned from my builder. And this is just one example, but not the only example. And every step of the way, he would say, how about changing this? Would you like to do so? Or he would say, oh, by the way, I changed this. I just want to make sure it's okay with you because talking to you, I understood that's what you really want. And here's a way we found we could actually do it. And every step of the way, they were re-engineering and redesigning. And I realized they actually built the house, and they've not a single time used the word called agile. And I'm like, wow, that's the beauty of this. People who do agile never say the word. And then, of course, they are absolutely agile in terms of how they were responsive, building it for the user. And this really changed my opinion about how things can be in the industry and how we could be really changing our decisions along the way. It's not about what was decided, but what can be better now, knowing what we know right now. But of course, as we all know, some decisions are very highly critical. And I came across one very recently that I cannot think of anything more critical than that. And I'm sure you all have faced that as well. And it's this. Just out of curiosity, how many of you do the one on the left, over orientation? There we go. Thank you. How many of you do the under orientation? There are a few people. That's okay among friends. In fact, this is a very critical decision because I got curious. And so on the way this trip, I paid special attention. I got my wife worried, actually. I have a list of places where I saw that toilet roll, and I have statistics now, whether it is over or under. Airplane, under. Lounge at the airport, under. Don't know why. Hotel, it's over. Well, which one is right? It turns out, in fact, now, you know how people are, they just won't say you're wrong and walk away, or you're right and walk away. And I came across this, which is even more amazing. And here's what it said. The correct way to hang the towel paper, hang it wrong way can result in absenteeism, workman's comp, and even business-busting lawsuits. Oh my goodness. That's kind of scary, isn't it? But as it turns out, the overhanging has its benefits. The underhanging, I was reading about it, and they said if you have a really young, small kid in the house, or if you have a pet, yeah, and he's demoing how they would be messing with it, so maybe you want the underhanging to, so there are good reasons to go one way or the other. So now I'm beginning to think, maybe I'll have half of them one way, the other half in the other way in the house, and maybe experiment with it. But again, as you can see, it's not a simple answer. This is right, that's wrong. Do you have kids? Do you have pets? Do you have other reasons? And hygiene comes into the picture as well. So on one hand, it's convenience versus hygiene. Maybe aesthetics versus, again, ease. Which one do you prefer? I would argue maybe the people who have the underhang have better aesthetic values than I do. And I really respect that as well. So very few decisions are really binary, where you can just flip and say that's the only way to do it. For example, ego. Is it good to have ego or bad to have ego? Let's think about it. You know, people tell me, oh, you should have no ego. Well, if I have no ego, guess what happens? I got low confidence. I can't even roll out of the bed in the morning. I wake up and I say, you know what? I don't think I'm worth it. I'm just going to be in the bed today. Low confidence. What if I have super ego? That's overconfidence, maybe even narcissistic behavior. Hey, I'm amazing. It's terrible. But we do have one ego, but enough to have that self-confidence, but not anymore. And, you know, this is one of the things that I love about things, right? One of the reasons I love family is the family puts us in the right place oftentimes. My wife, for example, she would look at me and say, so you give talks? I'm like, uh-huh. And people come to listen to you. I say, uh-huh. And she says, why? Now I'm like, okay, thank you, right? So the point is, that is where we need the balance between, on one hand, I can't get out of the bed. On the other hand, I'm narcissistic. Well, I do want to have enough self-confidence to what I do. So we need to think about it. Let's try something a little different, if you would please. Just turn to a person next to you and ask the question, how are you? Go ahead and try it. I can hear the laughter as well. I was in Umeå a few months ago to teach a course, and I had a fantastic group, and they taught me a few things that I need to think about. So the simple question, how are you? You can ask this question every day. Maybe somebody says, terrible. Well, I hope not many people said that. But I was born in India, but I have spent most of my life so far in the US. We Americans, you ever ask us, how are you? We're going to tell you, awesome, amazing, pretty darn good. We want to really absolutely be energetic, right? That's what we say. So when you ask the question, how are you? If you got some super exciting answer, you know who they are. But then I learned also that question has a very different response, a nice one. You're okay. It's okay. And a nice balance. Let's not get carried away. It's okay. We're good. We're doing good. Again, a nice balance. Not one extreme or the other, somewhere right in between, so we can focus on the work and get along. Now, some of us are optimists. Some of us are pessimists. I like pessimists because they are realistic. I like optimists because they get things moving after being realistic. But I came across this recently. I never thought about it this way, but I learned a new lesson. And somebody said, a pessimist and an optimist walk into a bar. That's kind of interesting. What could go wrong? And the bartender said, hey, how are things? And the pessimist replied, it cannot get any worse. And the optimist was quick to respond. Which is right. Do you want to be optimistic? Do you want to be pessimistic? Well, I think we need a balance there as well. We got to be realistic. Should I say yes or should I say no? This is a question we all ask every single day. The boss just walked in. Hey, I've got an idea. No. That's the easiest way to get fired. But what if you said yes to the boss when the boss said, I got a great idea? I had one boss who said, ship it. I said, but the code doesn't even compile yet. He said, that's okay, ship it. Do you say yes or do you say no? How do you react to this? The more yes you say, the less you would deliver. That's a lesson I've learned in my life. If I keep saying yes, I'm not trustworthy anymore. If I keep saying yes, I cannot deliver on my promises because there's only so much time on our hand where we can deliver things of quality. So does it mean I should say no? Well, as it turns out, we all go through this transition. We start as a novice. We end up as an expert eventually in whatever we do and in different things we do. When you're a novice, what are things in your mind? What are your concerns? You need opportunities. Because if a novice never gets an opportunity, they can never become an expert and transition in that journey. You want to gain that experience with those opportunities. When you're an expert, on the other hand, you want to maintain your reputation as an expert. And you want to be keen on succeeding. That's how you are an expert, and you have a reputation when you succeed, not if you keep failing. Now, this completely shifts our decision-making at this point, because as it turns out, when you're a novice, you want to say yes eagerly. Things I would say yes for when I was that young lad trying to get into the field. Yes, I can do this, I can do that too, I can do that as well. And then pull on more things to do. And that becomes exciting. But when you're an expert or moving towards an expertise, begin to say no nicely. Don't be rude when you say no. And I say no about 60 to 70% of the time these days. Not that I'm an expert, I want to be eventually. But I'm beginning to realize I cannot sustain saying yes to everybody. So when my clients call me and say, I got an idea, I'm like, shall we reconsider it? In a nice way. No, that's not going to work for us. So essentially what you want to think about is it a yes or a no? Well, when you are really as looking through, if you're a novice on one hand, you want to say yes, but as you're gaining more experience, you better start saying more no. And in that journey, you have to decide when that's the right time. And we are the novice and the expert at the same time for different things. You might be an expert programmer. Maybe you're a novice architect. You're going to say yes and no on the same day. That's okay for different things. And so that journey as you go through, so you are going to say yes in the beginning, but the more experience you gain in something, that's going to turn into a no, and there's nothing wrong with it. In fact, what's wrong is when you don't have the guts to say no nicely, because you are hurting yourself in the ability to progress at that point. So life, or living, is an act of evaluating trade-offs. That's what we do every single day. We are constantly evaluating trade-offs. We're not making decisions as to this or that. We're asking the question, what do I gain? What do I lose? And which is better for me? Every single interaction, every single thought is the trade-off that we go through in our mind. And it's a little bit easier for us in our day-to-day activity, but imagine building a house. You can imagine how many trade-offs we had to go through, my wife and I, as we went through it. Imagine building a software system which is very complex. We're going to go through those trade-offs as well. You can rarely decide on things in isolation. This is one of the things we should really be aware of. I cannot decide based on one thing. I got to think a little bit more broader as well. So the first and foremost, it's not a switch. Then what is it? And I, in my mind, visualize them as really these dials. And every single decision is a decision dial. And when you flip this on this side, you can't control that going on the other side. And your question is, how can I balance them so they are within reason? So it's no longer the question of, can I flip this and go home? What you're asking is, here is the range that I'm willing to live with for this. And here is the range I'm willing to live for this. How can I bring this within that range so this one is still within the range? That's what we are asking the question all the time. So I want to start dialing this, but without this going off the chart. And so it's a balancing act that we constantly evaluate when it comes to making decisions. For example, literally, that is the snow outside my house right now. And just about a week or two ago, it was close to minus 35 degrees. And when I said this, somebody said, is it Celsius or Fahrenheit? Like, does it matter? When I say it's minus 35? In fact, I was curious, so I looked up. And by the way, minus 40 is the best number, because it's the same in Celsius and Fahrenheit, meaning it's hell. So it was minus 35 outside. So you say, my gosh, that's pretty darn cold, isn't it? Yeah, it was extremely cold. I came out, and my mush was turning white with snow immediately because of the moisture. And it was horrible. So obviously, I want to turn on the heater. And guess what? If I set the heater at 75 degrees Fahrenheit, which is what, nearly 25 degrees Celsius, I apologize for these units, by the way, because I live in a place where we use ancient units of measure, and we are very proud of that. But you evolved people use Celsius, so I'll try to keep up with it. So 75 degrees Fahrenheit or 25 degrees Celsius, guess what? I can be in my T-shirt in the house. That's how cool that is. If I turn it down to 70 degrees Fahrenheit, 20 degrees Celsius, maybe I'll put on a little sweater. But guess what that temperature is? 60 degrees Fahrenheit, which is about 15 degrees Celsius. Venkat is in 6 layers of clothing when home. You say, really, Venkat, why? Because when I put it at 75, I am very comfortable until my wife tells me, we got the energy bill. And I'm like, uh-oh, dial it down now. So all of a sudden, I'm not making my decision as to what the temperature should be based on my comfort. It is also involves the comfort of my wallet as well. So I have to balance those two out. And I keep it at 60 and 6 layers of clothing. That's pretty comfortable financially and weather-wise as well. Again, my decisions tilt. My children come home from their places where they live, and they say, Dad, it's cold. I'm like, 6 more clothes will fix it. Because I don't want to be paying higher energy bill. It's a balancing act. We have to strike one more time so the decisions we make is not one-sided. Are you comfortable? Is a very interesting word, financially and health-wise as well. This is another thing that I've been thinking about quite a bit. Do I want to spend? Do I want to save? If I spend, I have less to save. If I save, I have less to spend. What do I do? Well, obviously, I need to spend. I need food. I need to, prepare for things. I need to protect my children, my family. I need a roof over the head. But are there other things I need to spend right now, or can I save it so I can have a nice retirement? So now we are, again, making this decision. I'm thinking about what I want today, but I'm thinking about what do I want 20 years from now, 30 years from now. In my case, 5 years from now, maybe, at the age I am right now. So essentially, the idea is I need to think about now, I need to think about later. This brings us to something that we can learn from. And Toyota, back in time, was really interested in manufacturing cars. This was way back in time, 70s. And they wanted to really manufacture cars and produce them and send it out. And what they found out was that their manufacturing was very efficient financially, but they found that their cost of maintenance was very high. Cars would keep coming back for repairs, and it would take a lot of effort, time to repair it. And so they were struggling with this and thinking, what can we do? Now, we can relate to this a lot, by the way, because if you look at the yellow line in the bottom, imagine that's a development cost, and you say the top one is the maintenance cost. As a manager of software development, you may say, hey, I have a budget, and I want to show to my company that I finished this coding in that budget. So I am going to ship code as quickly as I can, which may be great. But guess what? The company is spending a lot of time and money fixing bugs. And they are spending more and more time and money fixing bugs. What's going to happen in that case? I had a company, I won't mention the name here, that called me up from London, and they said, hey, can you come and do a TDD training for us? And I said, I would rather not. Why do you want to do TDD training? And they said, because we want to improve our quality, we want to ship better product. And I said, let's be honest about it. Can you tell me how much money you're spending in fixing bugs? This is a very serious question I asked. This was 4 a.m. my time in Denver, Colorado, middle of the day for them. And he's like, really, you want to know this question? I said, can you come and do training, and you want to ask me a question? I said, yeah, how much money do you spend on fixing bugs and errors? And he said, in my product, we are spending $1 million every year. And I said, can I be honest with you? He said, yeah, what's up? I said, don't do anything. He said, what do you mean, don't do anything? I said, look, let's be realistic about it. With all respect, when I'm walking, if I drop $10, I'm not going to run behind it, because $10 has very little value to me today. $10 for me is like $1 million for your company. Why are you going to waste your time? Don't do anything. You're fine. And he said, okay, let me tell you why we really called you. I said, now we are talking. And their CEO was giving a talk on a stage like this, and I hope this doesn't happen to me. And the Department of Defense of the US government walked up to the stage and served a notice in the court of law. It's an international company, and they had installed a product that completely wiped out the systems of the US government. Don't want to mess with them. And he said, we need to do better things. We need to automate a lot of things we do. So now can you come and work with us? I did, and they did phenomenally good, a great team. And I didn't even do training for them. I said, let's just start coding, let's pair up and do things. And it was a great experience. But come back to that question, why do you want to do this? Don't kid yourselves suddenly that you're going to change everything by doing this one thing, but understand the problem, the reason. Coming back to Toyota, what they did is they realized if they improve on their manufacturing process, they're able to reduce their maintenance cost. Now, if I only look at manufacturing, I won't succeed. But if I look at my overall holistic view, then I'm asking the question, oh, wait a minute. Do I want to spend less here, but spend more over there? And this notion, I keep reminding myself over and over and over. The local optimization versus global optimization. We often, most of us, unfortunately, focus on local optimization. What do you want to have for dinner tonight? How is the coffee? Hey, have you fixed this bug right now? Have you finished that report? The long term, do you have enough savings? How's your health? Are you doing really well? How's your cholesterol number? How's your weight? How's your other things? Are you able to really move around with agility? We tend to push those long-term things because out of sight, out of mind. That's 20 years from now, 30 years from now, 5 years from now. What's for dinner tonight? That's local optimization. But unfortunately, though, we humans are driven to think of what's now, and we tend to really forget the long term. And this is one of the things that was a rude awakening for me, is to say, wait, there is going to be one day I won't be able to walk around, I won't be able to work, what am I going to do for those days? Is the health, something in the focus? Yes, we are all busy, but we cannot lose sight of it. Local optimization versus global optimization. So the Toyota model that changed after that was, base your management decisions on the long-term philosophy, even at the expense of short-term financial goals. That really resonates with what we should be doing, not necessarily what we are doing as an industry. And so when we think of the long term, then we tend to really rethink about the short term. Now we say, yes, but wait a minute, let's rethink about it. Maybe this is a no. So my argument is survive in the short term, but succeed in the long term. There is absolutely no purpose in succeeding in the short term in order to fail in the long term. That's no fun at all, because the long term becomes a short term eventually, and we're going to dread it. So I want to survive in the short term, but I definitely want to succeed in the long term, and I want to keep, as an industry, I want to keep that in our mind as we go through. So be sustainable about what we do, and I always come back and think about sustainability. Can I do what I do in a pace in which I can sustain? Can I release product continuously with quality and be able to continue? Can I maintain a reputation of a company? Can I maintain a reputation of a team? Can I maintain the health of the team so they don't get burnt out and they quit the job? That's the long term I want to keep thinking about. That's maturity versus hypocrisy. And we need to build that in our industry as much as we can. When people tell me, yeah, but my boss, well, have a conversation rather than a conflict. Because when people begin to think, they begin to react differently, and that helps us. So living is an act of evaluating trade-off. But why talk about all this? Because programming is how we make a living. And that's part of living too. And it's not something we do at home versus work, because it's the same us that is at home and at work. It's even worse for a lot of people. The work is at home now, which is even worse. And so we need to really rethink about it, because if we don't, we cannot sustain that. And it's our responsibility, because there's one thing I always want to keep reminding myself. There is only one person in the world who cares about you, and you know who that is. And that's important for us to be taking care of ourselves. So in every step of the way, we need to think about it. Let's talk about evolution of software development. Long time ago, when I started programming about 35 years ago, the world did what is called the waterfall approach. I want to always say there's nothing wrong with waterfall, honestly. I'm not a person who would say, oh, waterfall, you shouldn't do it. Nothing wrong in waterfall except one thing, just one thing. And the one thing is that the time when you know that things are not going well, that feedback loop comes too late. If the feedback comes too late, what happens? If you get the feedback in the early stages, you're like, oh, that's not working, isn't it? We just laugh at it. Let's fix it. If the same feedback comes late in the game, that's called panic. You're like, uh-oh, my gosh, we just found out this is going, what are we going to do? The deadline is approaching. And when we get panicked, we don't think. We are irrational when we are in panic. This is one of the reasons why you want to push the feedback early on. At least that's a theory. So in Waterfall, we did big upfront design. And that was terrible. I know it. I did it. Because that's what we learned. That's what we did. But of course, I have a good news for you. Now we are doing agile development. What that means is no design. That's not for us. Hey, how do we do this? Don't worry about it. We are agile. What about this particular? Don't worry about it. We are agile. We'll figure it out. No, we don't. This is the other extreme of foolishness. Neither one of them actually work. In fact, I've got some people that I know who have beautiful names for it. One company not too far from here calls this Scrumfall, or other names like that. But doesn't really help. So what do we need? Well, on one hand, we have planned the design. That didn't work. On the other hand, we had the emergent design. That didn't work either. So what should we do? Now, one of the things I always tell people is, it doesn't matter to me what you call it if you're successful. And it doesn't matter to me what you call it if it doesn't work. So when people say, we do Agile, it doesn't work. Well, first of all, you don't do Agile. You be Agile. Nobody does Agile. And this is where we tend to forget the reasons why we do things, and we just run behind the bandwagon and say, we got to do this. Well, one of the reasons we do this is, as humans, we love ceremony. Ceremonies are beautiful, by the way. Hey, what do you do for Agile? We do Scrum meeting. We stand in a circle and we talk about it. Like, why? Because we love ceremony. Ceremony relieves you from real work. How are things going? The stand-up went very well today. We love ceremonies at the end of the day, but we got to break out of that cycle. So maybe we should consider what I would like to call as just enough design before we start coding in a certain area. Maybe an emergent design where we can direct the design rather than saying, yeah, we'll figure it out along the way. Again, a balance we want to strike about this. Well, I started programming way back in time using statically typed languages. Languages that would have compiler expecting you to specify the type over and over and over. I will be absolutely honest about it. I feared languages like JavaScript. And then, of course, JavaScript, Ruby, Python, oh my gosh, are you out of your mind to be able to program in those languages? There's no type information you specify. That was me of the past. Then I began to realize I had good friends who were really good at it. And they would look at me and say, Venkat, about 90% of the things you complain about, we never have issues with. What's the problem with you? I'm like, but it will fail this way. They're like, yeah, for you, but it never does for us. And I seriously, sincerely started looking into it. Today, I program in about 15 different languages. What I mean by that is I'm not good in any one of them. But I love those languages. And about more than half of this are dynamic type languages. Then I realized there is this idea of design by contract versus design by capability. Design by contract is where you specify with rigor, here is the interface. If you don't support the interface, don't come in. We want to verify that. We're going to have the compiler check things for us. So when you do design by contract, you got conformance, you got compliance checks by the compiler, you got fewer runtime errors. Definitely good benefits, no doubt about it. What about design by capability, though? You got flexibility, you got evolvability, you got extensibility, you got malleability. One feature I love, really love, is metaprogramming. Because metaprogramming gives me the ability to synthesize code so it can come up with behavior at runtime And I have used metaprogramming in languages like Ruby and Groovy and Python, and more so with the capabilities of JavaScript. I've really enjoyed metaprogramming even more. But how can I do that metaprogramming in a static type language? Not so easy. Kotlin pushes the boundaries quite a bit, but not entirely, because it's hard to do so with a design by contract. But here's a way to think about it. If I say we need really strength, so I'm going to build a car with only steel. Really, what is it going to have? Everything is steel. Seats are steel, tires are steel, everything is steel. You won't be able to sit in a car and drive when everything is built of steel. A good car, like any system, has things that are robust, but there are things that are malleable and flexible, so you have a better experience driving and a safer experience as well. So a part of the system has to be robust, part of the system has to be flexible as well. But when we entertain that thought now, we ask the question, should I use a dynamic type language? Should I use a statically type language? It's not a switch. I cannot say yes or no. I have to ask the question, for what part? Let's think a little bit about this. Well, Ola Beni has an interesting thought about what he calls as a language pyramid. And he says, when you build any serious non-trivial system, you really want to think about different layers in your system. You want a stable layer in the bottom, you want a dynamic layer on the top of it, and you have a domain-specific layer on top of that. And then he argues, when you have these different layers in a system, maybe you don't want to use the same language for everything that's in here. Maybe you want a different type of languages that you want to use for it. He goes on to give an example of this to say, maybe you can use Java, or maybe Scala, or Kotlin. You can use any of those languages, C#, that's fine too. You can use a static language in the bottom layer. Maybe the middle layer could be Ruby or Python or JavaScript or Clojure, any dynamic type language. And on top of that, maybe you can have a DSL for the domain-specific layers. So now we are thinking about this not as a, hey, do I want to build everything with a dynamic type language or everything with a static type language? Maybe that's not a decision I would make so easily. I need to rethink about it in terms of how I'm going to create it. In terms of design principles, similarly, we need to rethink about a few things. For example, what do you think, just arbitrarily thinking about it, right? Just relax your mind for a minute. What do you think about reuse? Is reuse good? Hands go up, right? So absolutely, reuse is good. We are being told, create something reusable. What happens if you duplicate code? You will have fewer friends. As simple as that, right? I mean, who wants to spend time with a person who keeps duplicating code? We're not going to have as many friends. So we want to create reusable modules. That's what functions are for, and be able to wrap them into objects and abstraction. What about coupling? Should I have high coupling or low coupling? What do you think? Decrease coupling, right? We have been told, oh my gosh, coupling is bad. Have loose coupling and low coupling, that's better. So when you look at each one of these as switches, we can turn on the switch, reuse, low coupling, we can keep going. Should I increase or decrease code duplication? Of course, no question. Remove duplication. Keep it dry, we say. So here is dry and reuse on one side. Here is coupling on the other side now. All of a sudden, we put them back together. Now, what happens? Here, I have low coupling. Yay, that's great. But guess what happens? I've got low reuse and more duplication of code. Because if I don't want to depend on something, I got to duplicate it. If I duplicate it, I don't have to depend on it. I'm hands-free. Then you say, well, okay, but I really, really want high reuse. Now you're like, uh-oh, we got to couple with it now. Which is right? Neither one of them is right. The question we want to ask is, what are you trying to do? And this is when programmers tell me, we want to apply design principle, I hit myself in the head, not again. Because you don't wake up in the morning saying, I want to apply design principles. I wake up so I can deliver value to my clients. I got to ask, what do you want to do? How can I make that work? That's a question I have to ask. I'll share with you one story I would never forget. I cannot mention the name of the company, but it's an insurance company. It's a company you probably know very well. It's a very large insurance company in the US. And I was sitting with the programmer working on their application. I shouldn't have asked this question. And I really wish the programmer said, I won't answer. That would have been better. But I asked, hey, this object, can I see the database table for it? He said, sure. And he opens the database table, and I'm staring at it. And I look at him and said, excuse me. He had no emotion. He just looked at me and said, yeah. I said, this table has 800 columns in it. He said, uh-huh. And I said, you have thousands of tables. Uh-huh. And every table has hundreds of columns. Mm-hmm. Why? He said, because they use it. I said, who? He said, everybody. I said, who is everybody? He said, every application in our business. This insurance company has thousands of applications putting their hand into that schema. Just imagine this for a minute. One schema which has everything. What's going to happen if you have a schema like that? Maybe you go for an interview with this company, and they're talking to you how wonderful they are, and then they tell you, you know what? While we are talking, we'll take you to the cafeteria. Let's have some lunch. We'll continue our conversation. And you say, yeah, that's great. So you're in the cafeteria having lunch with them. And you see people are having a great time, nice people talking. And then you notice, way back in the room, with nobody close by, there is one developer sitting alone and eating, facing the wall. And you say, who is that person over there? And they say, we don't talk about this person. And you say, really, why? What happened? And one person looks around and says, he tried to change the schema last week. So what's the strategy for this company? They will tell the developers, don't screw up. Hey, I want to change the schema. What? And there are people escorting you out of the room. You better submit a change request. And what happens? That goes to the architecture committee. Wow. What's that committee? That's where innovation goes to die. And by the time they come back with, okay, we reviewed it, the guy is gone. He's left the job already. So what happened here? Code stability takes precedence over business agility. Your business comes to you and says, we want this change. Hey, let's tell you how things work here. You see the schema? Nobody touches that. You go talk to your boss and let them talk to their boss, and they will talk to my people, and they will come down, and then we'll make the change. In about 8 months, we'll talk about this again. That's a disaster. Why did we do this? Oh, because let's talk about software design principles. Don't get me wrong. I'm not saying design principles are not useful. They are. But they cannot be the goal of what we do. They're a means to an end, not the end we strive for. So what good is anything we do if we don't have a clue why we are doing it and what benefit we get out of it? So encapsulation is an extremely important concept when it comes to microservices, for example. Now, I often say this. There are 2 things in my life I would not share. 1, toothbrush. 2, a database. Occasionally, with a close member of my family, I may even share my toothbrush, but never a database. Encapsulation is extremely important because the minute you compromise encapsulation, you drop business agility. If you say, you know what, we don't care about business agility, that's great. We can do anything we want to do in that case. But we cannot lose sight of the business. That's something we need to think about. So we're not saying duplicate with vengeance. That's not the recommendation. But what we are saying is reduce duplication, but prioritize encapsulation. So to provide better business agility where that is needed. And that's basically what we have to decide. And that's a decision we have to make every single day. So when I sit down with people, the minute we say, let's do this, oh my gosh, we will end up duplicating. Like, oh, calm down. We are not saying our goal is to duplicate. Let's ask the question, what are we gaining? What are we losing? Is what we gain more important and what we lose less damaging? Are we in a better place when we do this? So evaluate trade-offs. So if we don't evaluate trade-offs, we are making these decisions irrationally. It doesn't help us. It doesn't help the team either. Should I program imperative style or functional style? Well, imperative style, I love it for reasons like raw performance, exception handling, works really well, very familiar to a lot of us. We can just wake up and code in it. I like functional style as well. I'm not saying I like one and not the other. I like them both. But I like functional style because it's easier to parallelize the code. It's easier to maintain. It reduces accidental complexity. Which one should I do? I ask the question, what am I doing? That's going to make the decision for me what I'm going to do. On one hand, I got better maintainability. On the other hand, I may have better performance. I never want one or the other. I need to balance. What good is my code, which is great in performance? I had a developer come to me, sit down with a thud. And I looked at him and said, having a rough day at work, aren't we? He took a deep breath and said, I love Python. I said, I know you do. And I was in this other room, and I saw the people in that room writing terrible Python code. I'm angry with what I saw. I said, I can feel your pain, I understand. And he said, and they're telling me they're writing code like that, such a nasty code, because they want performance. And I said, is the code giving good performance? He said, that's a problem. It doesn't. So if you compromise quality to get performance, you end up getting nothing. And this happens a lot. Anytime I sit down and talk about, what about performance? It's like, what about it? Similarly, scalability and performance. If I give you more scalability, I may not be able to give you peak performance. If you want peak performance, I cannot give you scalability to the peak. And if I give you both, the cost goes to the roof. What's the balance here? So don't ask, is the code fast? I cannot tell you how many times I have this conversation every single day. Is it fast? Like fast for what? Does it run fast? Fast for what? So don't ask, is the code fast? Always ask the question, is the speed adequate? Because speed is just one thing we want, not the only thing we want. There are other things we need to think about as well. Maintainability, cost. How about scale? How about other things we need to bring in? Ease of understandability, right? How is it expensive to maintain? The cost of development, cost of changing code. A lot of things come together as well. So the end result of worrying about performance often is the worry and not the performance. And this is one of the problems we always have to deal with, because we keep worrying about performance every single day, and then we end up actually messing with the code, and the result is a worry, not the performance we were striving for. I remember this experience I would never forget. I'll be absolutely honest about it. I was writing a piece of code, and every time I sat down to write that code, I had to tell myself, it's like a little, Venkat watching over Venkat. Hey, don't worry about performance. Write good quality code. Make it easier to understand, easier to maintain. And honestly, Everything I would tell other people, I told myself, and I wrote this code. And I absolutely wrote the code. It worked. The test passed. I put into production. And guess what? How the code behaved? It behaved really beautifully well. You know why? Because there were no users. About a year went by, and I got an email from one of the users a year later saying, Venkat, on this particular page in your application, when we go there, every click is taking 15 seconds. What's up with that? I'm like, oops, I got to fix the performance problem now. And I immediately went to the code. Thank goodness the code is in the version control, obviously. And I said, performance, let me fix it. Boom, 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 boom. I spent 2.5 hours changing code for performance. And when I finished it, I ran the sample again, measured the time, and what took 15 seconds to execute after my effort now took 15 seconds to execute. And I felt like an idiot. I'm like, uh-oh, I fell into the trap myself, didn't I? I did not commit the code, threw it away, took a deep breath, walked around the building for a few minutes, came back and said, let me understand what a concept. And I profiled the code, which I should have done in the first place. I'll be honest, I didn't. I profiled the code because I thought I know how to improve performance. I profiled the code. And of all the code I had, beautifully written, tested, and good quality, one function took that 15 seconds. I'm like, oh, you're the culprit. It took me 10 minutes to find out what the problem was, fix that one function, that's it. The performance now was 33 milliseconds. I was blown away. And I'm like, wow, what an interesting way to really. Now imagine worrying about performance every line of code you are writing. For what good reason? Because the problem is not there, unfortunately. So when performance is truly a concern, I often tell my clients, write a test for it. Don't say it's got to be fast. Don't say it's got to be really good. Write a test for it. Tell me what that means to you. Why? Because if you put so much effort in improving the performance, you don't want somebody like me to come and refactor the code and the performance goes down the drain. And then you're back at it in 2 months from now. Write a test for it. The test is keeping an eye on it. If anybody modifies the code, it says, wait a minute, the code may work fine in your expectation, but the performance is not good enough, go fix it. So if a performance is important, don't fix it, write the test for it first. Then come back and look at the performance issues. So designing and architecting is evaluating trade-off. That's what it really is. Designing and architecting is really every step of the way evaluating the trade-off. It's not a decision we make, it's a trade-off we evaluate constantly. So identify the essential characteristics. Ask the question, what is important in this application? Speed, scale, security, performance. Keep listing them, testability, interoperability. Whatever that could be, list your characteristics. Now you ask the question, what are the ranges for each of these that are acceptable? What is the operating range for these things? Can we now architect and design so things can be within the range for all of those things? That's a question we want to ask. So prioritize what is really important among the characteristics and evaluate the trade-offs that you have to deal with. And don't make binary decisions. I like this, I don't like this. I want this, I don't want this. No. Hey, we want to bring this in the range without really violating that one over there. So decision-making is an optimization problem. It's not a binary problem. It's an optimization problem because you want to bring multiple things into the fold so that you can keep them all within the range you are expecting. And so it fundamentally is an optimization problem, not a binary decision you can make in what you do. So decision-making is an act of considering compromises. That's what we do every day. What is your role as an architect? What's your role as a senior developer? to walk in and compromise and ask the question, can I tinker with this so that comes within the range? Is that acceptable? And we negotiate with our customers. I often tell my developers, if you ask me one thing I would request you to do, please don't do this. Never go to your customers, your business analyst, and never ask them this question: is consistency important? Terrible question. The minute you ask them, is consistency important, they get really flustered. Of course, it's important. But then now you really told them there is something you need to worry about. Next week, you are in the cafeteria having meal. They come to you and say, I got a question for you. What is it? That consistency you talked about, you're maintaining that, isn't it? And they will hunt you down from now on because you told them, anytime you put priority into something you don't really need, you lose something else that is absolutely essential because you cannot have them all. That is, to me, the biggest pain. And so, do I really need it is a question we need to ask. So the most important thing we need to document in our journey, because we come back 6 months from now and say, hey, we decided to go this way. Why? So the most important decision is why. And we need to document the why. And I will end by saying what you already know, but it's important to re-emphasize. The most sensible answer we can ever give, it depends. Thank you.